fixing washing machines, dishwashers, I guess, whatever they are. Charred his stuff and stuff didn't fit. I just got a shipment in from China that apparently FedEx had for a month and were unwilling to give to me until I gave him a big hassle today. These 3.2 volt, 15 amp hour Lidl cells, lithium iron phosphate. I got one opened up just to see how cool it was. I've been waiting for these for 3 months. And so I'm gonna unbox all these and then we'll do some voltage tests on them. We're hanging out in this house just before the final inspection. And so they're getting ready to move in here at some point soon. That's pretty cool. And so I'll just test these all. Hopefully they test around the same voltage. The Inja's wife's baby shower. So they're having a little party out there and we're having some fun in here. So I don't envy what they're doing. So this was actually a shipment that I got in for a different project. It's the cross cars that I've been working on as well. But I did the same process with the larger shipment for this Ducati conversion. I just didn't have any footage of those cells getting unboxed. I also did not have footage of me putting together the battery holders and outlining the design of the pack. That would be on the Inja's video that he posted as well. But it did include 3 modules, just like the one you see here. At this point, I'm straightening and cutting the 8-gauge copper wires for the parallel connections. Because I've actually got 8 cells in parallel by design, but the pack is only 6 cells wide, I had to jump across 2 different rows in some cases. And so I've actually got different lengths of parallel connections of my 8-gauge. Some span across all 6 cells, some span just 4, and some span 2. And then I actually run connections across rows perpendicular to the original bars, which allows me to connect multiple cells from different rows. And you'll see those go on shortly. I went with soldering each of the terminals of the cells rather than doing a laser welder, largely because the cost of a laser welder is very prohibitive. But as long as you have a large soldering iron with a lot of thermal mass and you're careful to quickly deliver the heat down and pull off as soon as you're able to, you end up not really having any risk of damaging the cells too terribly much. In this case, I am confident there was not any damage given to the cells as I did this process. Here you can see those across row parallel connections going on. A good rule of thumb as you're watching this video is if you see any 8-gauge circular wire going down, you can be confident that's a parallel connection. The series connections all went on top of that later, which you'll see coming up shortly. I decided to not skip any of the work that I did and show you the full process. You get an idea for how much work is involved in this battery in case you have the intention or desire to replicate. And so you're gonna actually see me do this process of parallel connections 6 separate times because there are 3 modules and parallel connections are on both sides of those modules. So it might look a little bit repetitive in that regard, but you get a full idea for what work was done in this process. It might look a little bit clumsy or haphazard as I'm laying those bars down, but there isn't any risk of sparking as of yet because nothing is connected, and if 2 different cell groups touch, it'll just be a series connection. You won't short circuit anything. So I kind of just connected one end and worked my way down each of the bars to kind of solder those down, making sure there was contact firmly with each of the cells as I did that. I used a little set of pliers for most of my handling of the wire, and that was extremely helpful. They were spring-loaded, I mean, kind of more like jeweler's pliers almost, but it allowed me to very precisely handle each of the bars as I was laying those down. So I would first lay solder down, and then as that was heating, I would grab my pliers and be able to apply pressure down to make sure there was firm contact. So you'll notice my right hand kind of switching off between implements, solder, and pliers, while my left hand just continuously uses the iron.
Now that we finished all the parallel connections, I started to get started on the series connections, which is a bit of a learning process, honestly. I wanted to make sure that I designed them in a way where they were set up to not have too many cells delivering current down any one of the bus bars. And so the amount of copper on here actually is equivalent to two gauge cables at each series connection. Each of those bus bars is roughly a 6 gauge connection by cross-sectional area. And so there should be more than enough current capacity between each of those before it becomes any issue where there's not going to be any single cell facing higher demand than other cells. I did connect them between each of the cell terminals, so I actually just soldered those directly down to the tops of the bars in a place where it wouldn't be sending heat directly back into a cell. And this is the positive discharge, which I stacked a few bus bars up on top of.
All right, fellas, here is the Ducati. Got all the gas components taken off. Some of it actually is sold already. The engine is sold. I think the exhaust still waiting to be sold. So we're trying to, get some of that stuff taken out. Obviously, one of the things that was mentioned is the fact that the swing arm actually goes through the back of the crankcase. So the engine and the transmission combo that they have, that unit there, actually is structural, and most important thing that it does is connects to that. So we took the back of the case and made a template and have components in to recreate that little piece there. We have the stock bearings and everything that'll go in, and so we're going to recreate that as it sat. And we'll keep it as far back as possible, which leaves this whole space in between here for a battery. Obviously I could start doing this, but man, when cells come in, you know where I'm heading. I'm heading towards battery land. And so it's a 3-module pack. First one I have up here on the edge. I've got the series and parallel connections done on there. The rest of these have the parallel connections good to go. Each of these modules is roughly like a 35 volt total voltage. When you add them all together is 102 nominal. And so my goal is to build them all separately. The voltage is low enough that you can't shock yourself on them. Really, unless you're wet or really thin-skinned, which is ironic that there's actually a functional meaning of the term thin-skinned. I'm actually going to cover them in ABS plastic and then some rubber spacers between those. And so these will be really well separated. They're gonna kind of sit in the bike like this, and this is quite scary if you realize that, or if you think that they're live, but nothing's connected in series. These can actually touch, nothing can happen. But they're gonna stack up, all 3 of them here, spacers and plastic between each. The discharge, positive discharge, I've got it on here. You can see I've got a couple of layers of my bus bars stacked up until ultimately it's 3 thick. What'll happen is we'll just solder on the 2 gauge cable right to here, and then it'll run through the pack, ultimately terminating at the front. And so that's the back pack. And so it's actually gonna run all the way through. BMS is gonna sit right in here. Then the negative discharge will pop off right here. And so they'll run through positive and negative out one of these. And then we'll have the place that exits right in the front there. On top or front, I'm not sure which. Controller will sit on top, and so all the wiring will, be real short right in here, and then the cable for the motor will come up the back and then plug into the controller on this side. So you will have that one wire coming up. Otherwise, everything else is going to be contained right in here. We'll have shunt, contactor, everything will be housed right next to the controller, so it'll be just on top of the battery, a section for electronics. You won't see any of it. It'll be inside of the gas tank. So it'll look pretty cool. Obviously, I'm more function over form, and so my goal is just to build the biggest pack that can fit in there. It'll be sleek because it'll be in line, obviously, with your, the bike, so your legs will be on either side of it. But we're getting really close on this. The fact that the voltages are adding up now, that's how I always feel like all the work feels kind of slow. Then once the voltages start to add, I feel like we're on track. So you can see on either side, we have the series connections made. So parallel, and this pack is interesting because it's 8 in parallel, and I only made it 6 wide because we could not fit 8 wide in the pack. It works out well because we've either got rows of 4 or rows of 6, and then each of the cells that are not in the main row is connected, and then discharge, or like, you know, the bus bars that connect the two series groups together, always are matched in a way that only one cell current has to travel down these 8 gauge bus bars. They can handle more than that, but I didn't want anything to be a point where heat would build up. I have basically 2 types. We have a 6 to 6 contact, in which case they're all built like this, and then we have a 6 to 4. All my 6 to 4 contacts look like this, where they're set up like this, right? As you can see, it's the opposite, but it's a 6 to 4 again. Then we have a 6 to 6, a 6 to 4. So I kind of picked a model that would work, and now it's just gonna get repeated over and over and over again. There's only gonna be 2 instances where there's a discharge. In the other cases, so like on the back of this one, that bottom set is actually gonna be connected to the next pack over. So I'm just gonna have probably 8 gauge. We'll connect the 2 modules in that way, and then they'll just fold up. The other one actually has to go, I wanna say it has to go from here up to the top, and so we'll just run cables. So, you know, the same way that if you ever have to jump, you'll have to run a cable. We'll do the equivalent of a 2 gauge cable, since that's effectively what the discharge cables will be. That's kind of how I'm sizing everything. 2 gauge is my end goal. So everything that's in the pack adds up to more than 2 gauge as it goes. And then, because we're doing a 2 gauge, as long as we're at least 2 in every instance, we're gonna be totally fine. Actually, I think it has to jump from the top down to the bottom. That's what it is, yeah. So it goes top down to bottom. As it takes shape, I'll keep you guys updated. A little out of order. The battery is not the part that I really should be doing first, but it's the most fun for me. It's the most work. And when you get it done, you feel like the bike's alive. You know, it's what drives the rest of the systems. So if I have that done and we install that, the bike to me feels like half done already, just because the battery's kind of the biggest part of it. So from there, I continued working on the series connections, and this is the second of the 3 modules I had to do, and it's kind of more the same at this point. As I was going through those modules, I did come up with a strategic way to solder those down. I ended up just putting a dab of solder in the middle so that the heat would transfer from the iron to that copper bar, and then I could sneak the solder underneath the corners. So at the point where it was hardened, it was completely continuous connection from the bar down to the 8 gauge parallel connections. And I did hit solder on each of those points where it contacted that 8 gauge wire. So on the longer stretches, the longer bars, I ended up putting 3 or 4, depending on how many pieces of copper it was sitting on top of, but it was soldered at each point. And then at the end, you see here, I'm actually connecting a copper bus bar where it jumps between packs. I wanted it to be able to carry the current that it needed to from one pack to the next by getting it to the wires correctly. So each point where it jumped between packs, I made sure that I had a bus bar on the bottom there as well. And here I went ahead and drilled out holes for the BMS leads to be passed through, and you can see I'm actually soldering some little 22 gauge BMS wire onto the positives of each of the cell groups, and that allows me to insulate and cover those up without me needing to access those again, so that I can just solder my BMS wire straight onto that lead that sticks out rather than needing to open that up once it's in its final form with the modules sandwiched together. I'm putting down some ABS plastic here. I just went ahead and glued that on top of the bars. And each exposed set of battery terminals was shielded in that way, covered up with about a 16th inch thick ABS plastic. I went ahead and actually cut off all of the extra connection tabs on my brackets, my cell holder brackets, just to save space. And then I put some garage door insulator rubber between each of the modules to get extra cushion and separation so it didn't wear through as time went on.
Here I'm wiring in the BMS. I went ahead and dropped some solder down on the B negative port, connected a wire to the negative discharge, so that was hardwired in for charging. And here I'm putting together the first two modules. I had to run the wires from the bottom of bank 1 up to the top of bank 2, and so I actually needed to get the spacing correct, and I had to do that by getting them on the ground. But I did also use a square and a level to make sure that those were lined up correctly so they'll fit into my case just fine. And here is the bottom-to-bottom connection on modules 2 to module 3. And I just used some wire that I could fold over, and then I used some plastic to temporarily hold my modules together with hot glue as I was flipping them over and making sure that their width and spacing was all correct. Then I routed my BMS wires down. The first 10 cell groups were on the first module, and then it went, 11 more and 11 more until I got my 32 total. But I had to make sure that I ran the correct wire to each of the correct cell groups, and so as I passed them through the holders into the modules 2 and module 3, I had to make sure I knew which wire went to which cell, and so I had to actually line them out very carefully and kind of glue them down in their correct order on top of the cells, so I can keep track of which one went where. And here I went ahead and ran those down and connected them to each of the correct cells. The first bank was easy because the balance wires were long enough to reach all the cells. I just kind of glued them in line, keeping it super thin, 1 wire thick, so they're all flattened out like a data wire in a computer kind of. But the second and third modules, I had to actually extend the wires, and so I went ahead and had to heat shrink and solder in an extra extension of wire to get them to reach the correct cell group. And I did use a thicker gauge wire, so there wasn't any extra resistance in those groups that went into the second and third module.
So here is the finished product. All I've got to do really at this point is attach connectors for charge and discharge and put it in a case, which means fiberglass covering and then into an aluminum rectangular box. I would guess right now it's about 160 pounds. With the case on, it's going to add another 25 pounds or so. So we're looking at almost 190 pound battery. But the BMS is an 80 amp BMS. Obviously I have bypass discharge, as I always do. As long as the controller has a cutoff and it's balancing while it's charging and discharging, you don't need to have a low voltage cutoff on a BMS. And so this is just an area where heat could build up if you were to run it through here. With this unit, we're going to run 350 to 400 battery amps out of it. And so if there was, obviously you got to have an expensive unit to do that in the first place, but that's just an area for heat to dissipate if you're running through that at all times. So we're just going to discharge straight out of these cables here. I'm going to actually have the discharge come up right here, which will then connect to the controller, which is on top. The charge will come, which is right here. The charge will come out the side, which will allow it to be plugged in right here. You'll have just a DC plug, same kind that's used for like computer monitors, power cables, and that will just sit right in there on the outside of the case, so you can just close it up, pop it open, charge it, and then close it up when you're done. Balance wires actually were a bit of a trick because I had to run them in such long regions. I had to extend them, as you can see, for some of these longer runs. But I had to also make sure that I connected each of the correct ones to the correct cell. And so as I run them across this here, I have to make sure that I line out which one goes where. So it actually was a little bit of a trick. Obviously with any BMS, if you look at it from the top, the first cell, which is always black, goes to the first cell negative, and then everything else just goes to subsequent cell positives. The next one goes 1 positive, then 2 positive, 3 positive, all the way down the line to 32 positive. The blacks and reds from here don't mean anything because they're just these harnesses come standard with the first one black, last one red. but they're all just going to each of the positive cells from there. I couldn't put the BMS in until I had them all lined up with the cells stacked. And so what that meant is I couldn't access the positives of the cells. So if you caught during the time lapse, I had a jumper wire come off that was soldered on and then it ran through. I drilled holes in each of these these big circles here. So I ran these down beforehand so that I could then, when I connected here, I could just solder in and heat shrink, and that was all protected. I had to keep it flush, so I kept it 1 cell thick, which is the thickness of the spacers, the brackets. And so I don't have anything sticking out. Obviously there's going to be an aluminum case fairly close to here, so keeping distance. The fiberglass will keep a little bit of space between the two, but keeping distance and keeping this flat is super important. So I just ran down and had the 1 negative coming here, and then 1 positive, and then 2 positive, 3 positive, 4 positive, and I labeled each of those on the side so I knew which one was which, 5 positive, 6 positive. The other 2 modules I ran same thing, but it started at 11 positive, I believe. Yeah, 11 positive, 12 positive, 13. So I'm just peeling them off one at a time as I go down. The way the packs lined up, I had to connect 21 positive and 22 negative together. So I actually had to have a jumper cable here. This one, I had to run from 10 positive up to 11 negative. And so I actually ran, you can see the cable here. I ran this cable up from the bottom. I did 2 8-gauge on this side, up to the top here, and connected it to this bus bar. Each time I connected, I had an extra bus bar across the top, a thick, equivalent to roughly 6-gauge bus bar. And I did the same thing on the other side. So each instance where I had a cell that I had to jump to, made sure there was a bus bar in addition to the 8-gauge on each parallel connection that I already had. So we had really even current distribution throughout this battery. It's, of course I think so, but it's a really careful design. The one thing to be careful of is with these cells, obviously everything in here is soldered, but I have a large soldering iron that has a lot of thermal mass. I can quickly heat it up so that it adheres, and so I did that with each of my cells. From there though, in order to not have much unnecessary heat applied, I made sure that all of my series connections and that sort of thing were not over the top of a cell terminal. They were in between cell terminals. And as we got more and more copper on here, the heat dissipation increased, and you could solder, and then almost immediately after soldering, you could touch it and it wouldn't burn you. I just attached the positive charge cable, which is a 6-gauge next to a 2-gauge on a 3. Each of my discharges, I used either 2 or 3 thick bus bars. It's covered in glue, you can't really see it, but right here is 3 thick. Just because I wanted to make sure that anytime something had to run down the line, it had plenty of cross-sectional area with almost no resistance, so no heat would build up or anything like that. But when I soldered onto here, I hit that 6-gauge, melted it in, and then I could touch the bus bar on the top within like 3 seconds afterwards without getting burned. It will sit in my case perfectly. So I was really careful to line that up with a square and with a level and just make sure everything sit in there really well. But at this point, I'm just going to throw the case on. I still have to explain this all for the video the Inja's doing, but I'm gonna start getting this ready to build a case for it. Inja's gonna work on fixing the swing arm, fitting it so that it fits the hub motor. And once that's in, we throw the controller on and it's ready to program. I mean, as weird as that sounds, it's just, there's very little actual fabrication work that has to happen in here. It's all gonna be here, fitting this, and then making sure the battery fits. Design the battery to be exactly the right size to do that. We're gonna cross our fingers that we didn't get over ambitious and have not enough tolerance to fit everything. But I don't believe we're gonna have an issue, but you know, when you're sitting at this stage, there's always a little bit of worry of is that all gonna fit in there correctly? I think the answer is yes, but we'll find out shortly. So I actually built a cap for the top and the bottom out of fiberglass. I did 3 layers thick of each of these large pieces, and then the corners I did 3 to 4 layers depending on what I felt the need was. But my intention was just to
make sure that the structure of the modules stayed intact as it was sitting in the aluminum housing, and also wanted to give it a little bit of space and a little bit of insulation from shaking around against that metal there. So it was very form-fitting. Basically, it just is a secondary guarantee that the modules don't move. Obviously, they're encased on the outside edges, but each of the modules has a little specific imprint in the fiberglass that kind of makes sure it holds it in that shape. So once they were dry the next day, I just went ahead and, with some breathing protection, cut off the extra fiberglass there. That's a pretty nasty compound to have floating around in the air. And then I checked on fitment, and everything ended up looking really good. And so I glued down the cap to the ends and also in the middles just to make sure it sat very tightly against the cells and didn't take up extra space in the case so that everything could still fit easily. I checked the fitment of the top and ended up finding out where I wanted to cut my hole for the discharge cables, and so I cut that out with my multi-tool and I routed those cables up through the top. And that wrapped up everything on the build, and so from here it's just putting that case together and throwing it in, which I will show you guys next time.